This is problem 4 of the 2022 MMATHS Individual Round, and the problem reads, Kat and Claire are having a conversation about Kat's favorite number. Kat says, my favorite number is a two-digit perfect square. Claire asks, if you picked a digit of your favorite number at random and revealed it to me without telling me which place it was in, is there any chance I'd know for certain what it is? Kat says, yes. Moreover, if I told you a number and identified it as the sum of the digits of my favorite number, or if I told you a number and identified it as the positive difference of the digits of my favorite number, you wouldn't know my favorite number. Claire says, now I know your favorite number. What's Kat's favorite number? All right, so this is a logic type problem. So to solve this, we are going to need to use these clues that are given to us in order to find Kat's favorite number. So first of all, we're given Kat's favorite number is a two-digit perfect square. And already that tells us a lot because the only two-digit perfect squares are the following numbers: 16, 25, 36, 49, 64, and 81. That's 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and 9 squared. So we're already down to just 6 possible favorite numbers. And we still have a lot of ground left to cover because Claire asks, if you picked a digit of your favorite number at random and revealed it to me without telling me which place it was in, is there any chance I know for certain what it is? And that actually tells us a lot. For example, if Kat tells Claire, there's one of the digits of my number is a 2. Claire looks at this list that she already knows and she says, well, okay, only one perfect square has a 2 in it. That's 25. So if Kat told me 2, his favorite number would be 25. So 25 is still a possibility because Kat says, yes, there's a chance I know for certain what your favorite number is. So 25 is still in the running. However, a number like, for example, 16 is not. Because if Kat tells Claire one of the digits is 1, Claire is not sure whether it's 16 or 81. Furthermore, if Kat tells Claire 6, Claire would not be sure whether it's 16, 36, or 64. Meaning that 16 doesn't work because no matter what digit Kat tells Claire, if his favorite number was 16, she wouldn't be able to tell what the favorite number is. And similarly, we can use the same logic to keep 36 because there's a chance Kat tells Claire the digit 3, and Claire would immediately know that it's 36 because 36 is the only two-digit perfect square with a 3 in it. And similarly, 49 is still on the table because it's the only two-digit perfect square with a 9 in it. 64 we can still keep. Actually, we cannot keep because if Kat tells Claire 6, well, you don't know if it's 16, 36, or 64. If Kat tells Claire 4, you don't know whether it's 49 or 64. So 64 is off the table. And we can still keep 81 because if Kat tells Claire 8, Claire immediately knows that it's 81 because 81 is the only perfect square that's 2 digits and has the digit 8 in it. So now we've gotten the list down to just 4 numbers, and we can use our next clue. Kat says, moreover, if I told you a number and identified it as the sum of the digits of my favorite number, or if I told you a number and identified it as the positive difference of the digits, you wouldn't know my favorite number. What does that mean? It means that, let's say, for example, Kat's favorite number is 25. The sum of the digits of 25, and actually I'm going to make a column because we're going to do it for all of these numbers. The sum of the digits is 2 plus 5, which is 7. And the difference, positive difference, is 5 minus 2, which is 3. So Kat says, if I told you a number and identified it as the sum of the digits of my favorite number or the positive difference of the digits, you wouldn't know my favorite number. Meaning Kat could say the sum of the digits of my number is 7. And Claire wouldn't be able to tell anything about Kat's favorite number. Or Kat says the difference of the digits is 3, and Claire says, I don't know what your favorite number is because there could be multiple numbers that have this property. But we'll see if those two statements are actually true for 25 as well as some of the other numbers. So let's go ahead and calculate the sums and differences of the digits. So the sum of 36 is 3 plus 6, which is 9, and their difference is 6 minus 3, which is 3. The sum of the digits of 49 is 4 plus 9, which is 13. Difference is 5. And the sum of the digits of 81 is 8 plus 1, which is 9, and their difference is 8 minus 1, which is 7. Now let's look at the statement. If I told you a number and identified it as the sum of the digits of my favorite number, you wouldn't know my favorite number. And what does that mean? It just means that if Cat's favorite number is 25 and he says the sum of my digits is 7, Claire, using our previous logic, would look at these four sums and say, well, the only number that remaining on this list that has digit sum 7 is 25. So 25 violates this last clause because Claire shouldn't be able to tell what the favorite number is. And similarly, 49's sort of off the table because 49 is the only perfect square remaining with digit sum of 13. And now let's look at the differences, because if Cat tells Claire positive difference of the digits, Claire should not be able to tell what the number is. However, remember, we aren't eliminating 25 and 49 in the context of positive difference because we have not been given the information regarding the sums. So let's look at, for example, 81 we can eliminate already because 81 is the only perfect square remaining that has difference 7. So if Cat tells Claire the difference of my digits is 7, Claire would immediately be able to say 81. And that really leaves us with one remaining perfect square, 36. Because 36 shares digit sum with 81 and digit difference with 25. And therefore, if you're given 9 as the sum, or if you're given 3 as the difference, you're not going to be able to tell which perfect square is the right answer. And using this logic, Claire knows that Cat's favorite number is 36, and we are done. Thanks for watching, and I will see you next time.